Welcome back. So today we're going to start up with application of integrals. So keeping in mind all the formulas of integration and each and everything, each and every concept, we're going to do with the applications, that is how to apply with integration in our daily working styles. Okay, so first, whenever we need to find out or there is a question on area bounded by the curve, that is, what is the area below this curve that is covered by this curve. For example, this is my x-axis, this is my y-axis, and this is my curve. So I have to find out what is the area that is covered with this curve and what that is the shaded part of this area. Okay, so how do I find out with that? There is a very simple formula that we are using. For example, if my area is bounded in x-axis, so I'm taking up with the starting point of A and the ending point of B. So my formula that will be used for area is integration sign, okay, within modulus, because we'll take up with the positive values, and then limit a b, that is from where it's starting and where it is ending at that point, and then at fx and integrating it with dx, because we are having variable here x, so we are differentiating, or sorry, integrating with the help of dx, and again closing with the modulus. Okay, so this is all about the positive side. Now, if I'm having an integration or the area bounded by the curve is on the negative side, then how will I do that? Formula will be same. Diagram will be something like this, where I'm having an curve within the negative area. So it will be y equal to fx. Okay, a, b. Again, this is my x-axis, this is my y-axis. So we're going to find out with the area, which is equal to integration a, b, fx and dx, closing out with the modulus. So this is very important to understand. Whenever you need to calculate with area bounded by the curves, you have to use up with this formula particularly for working with the integrations. Now coming on to next point, whenever we need to find out the area that is bounded, like again we are going to do with the uh, boundation of the curves that is on either on x-axis or on y-axis. But now we are going to do when my curve is falling on y-axis, that is the starting and ending points are on y-axis, then how will I find out my area? Okay, so there we will be using a formula. Area is equal to C and D. Here I will be using function of y and differentiating it with respect to y, but I will be taking positive modulus. So my values are like this, and then taking up with the curve, formula will be this, whether you are working with the diagram on positive side. For example, if this is my diagram and these are my limits, so my curve is falling on y-axis, so I will be using with the formula where this is my C limit and this is my D limit and this is my curve, and I'm finding out the shaded region below this curve. Okay, so it can be either on positive side and this can also be on the negative side as well. That is, diagram will be something like y-axis, x-axis, and my curve is falling here, and I'm finding out the shaded region, and this is C and this is D. So either my curve can be on left side or my curve can be on right side as well, and will be finding out with the integration. That's why we are using up with the modulus sign, because we are taking up with the positive values. Okay, so now coming on to next point, when we need to find out areas of two curves, that is, for example, if for example like this is my x-axis and this is my y-axis, and I am having a curve something like this. So this is my first curve and this is my second curve, and I need to find out the area in between them, that is the common region we need to find out. So how will I do with that? What all formulas I will use? For example, now I'll be using the formula that I'll be working with. Now y is equal to fx, for example, okay, and next function is equal to gx. This is my first function and this is my second function. So what I'm gonna do is, my x values are same for both the functions, okay, so they are leading from a to b. So this is a and this is b, okay. So what I'll do is I'll use up with the formula integration a d, okay, fx minus gx and dx. So how did I did this formula? Okay, so simply you can understand with this formula, whenever we are finding out with the area of a simple curve. For example, this is my curve, okay, so I will find out the area by integrating and I'll get the curve below this, right? And then for example, this is my another curve, so if I'm integrating this, so I'll get the area below this, right? So if I'll subtract this area from this area, then I'll get the common region that is in between them. So similarly we did this here and we are using this formula. Okay, so here the values can be negative as well as positive, but whenever you're working with the shaded regions, you will take up with the positive value. So we will take up with modulus here. Okay, now last thing, whenever we are having positive and negative values, so how do we work with that? Okay, so this is very much important to understand. Just listen carefully, because this area bounded by two curves is mostly asked in exam that we have done just now, and also there are many questions that fall in between, um, for negative and positive regions both. So we need to break up with the working part, because that makes our question work easier. Okay, so going with that, for example, if my diagram is something like this, where it's falling below and above the x-axis, okay, so and my limit is going from again a to B. Okay, so now I'm having A region, this region for negative and this region for positive. But curve function is same, right? So how will I do this? For example, we know that sine function, cos functions are of this type, right? So how will we do this? Basically, my function will be bounded from a to b, fx and then dx. I will have to break this function in two part, that is starting from a to k where it's breaking, and fx I'll take up here, right, and I'll take dx. I'll integrate it and find its value. Another, I'll add up and change its limit from k to b, and then take up with fx. I'll not take up with the modulus here, it's like this. So we have sum of two functions here, as we can see, a to k and k to b. So we have two functions and we'll sum them up, so we'll get a particular, like you will have two answers and you need to find out with the same like simple value that you will get. Okay, like for example, if you get minus 10 with the first part and you get 10 with the second part, so you will end up with 0. You have to make sure that you find the final answer. Okay, so such type of easy questions are not asked. You will have to integrate them. Okay, so like I just told you with the sine function, right? So if I'm given that sine x is my function and I have to find the area bounded by the curve, so I will require a value, I'll require b value, and I'll require the point where it's intersecting on the axis. So that is the point, and then I integrate it from a to b, and I'll break it in fact from a to k and then from k to b, and then I'll integrate them both and then add them up. So I'll get a proper answer for its value basically. Okay. So these all are types of functions that we mostly use in application of integrations. Thank you very much. Meet you in next class.